Let's do this rational exponent, right? So let's do 3 times x plus 1 to the 2/3 equals 12. Hi, I'm Sarah. I've been a STEM and math and science teacher for 20 years, and I'm here to make math and science engaging and fun and not so scary for everyone involved. If you're looking for private one-on-one virtual tutoring, please click the link and do the stuff, and let me know if you have any comments, questions, concerns, any content that you need help with. I have Cameo tutoring. I have all sorts of resources. Now, just like we did with the radical equations, we want to get that x by itself, but also we just want to make sure that we've got that by itself because this is technically like a radical symbol. So we're going to divide both sides by 3. Okay, so we still have x plus 1 to the 2/3 equals 4, right? So now this is where you get into that like whole multiplying by the reciprocal. It does cancel it out. So this is kind of going into like multiplying by the reciprocal. It's doing like exponent rules, all that kind of stuff. So what I'm going to do is I am going to put this I'm going to multiply or put this to the 3/2 power. Now, what that's going to do is this 2/3 times 3/2, those are going to cancel out. So all that's left over here is x plus 1. Now, over here is where it gets pretty interesting. So we still have to multiply this or put this to the, oops, not the 2/3, put this to the 3/2 power. Okay. Now, when you have a rational exponent like this, the denominator becomes the radical, like the root, and then the numerator becomes the power. So this 2 drops down to make this a square root, okay? And remember, plus or minus, right? Plus or minus the square root of 4 to the 3rd. Rational exponents are kind of bonkers, right? So the denominator, so here we have the denominator, which was 2, and that became the root, so it's a square root. And then this numerator became the exponent, which is pretty cool, right? So we've got 4 to the 3rd, and what's 4 to the 3rd? Well, 4 squared is 16. 16 times 4 again is 64. So now I'm looking at x plus 1 equals plus or minus the square root of 64. What is the square root of 64? Plus or minus 8. So we've got x plus 1 equals plus or minus 8. So this is where we kind of split our values, right? Either x plus 1 does actually equal 8, which means that x equals 7, or x plus 1 equals negative 8, and x equals negative 9. Right? So we're going to check these by plugging these back in, right? So if we plug it back in, we would get, and it's easiest to just do this on your calculator, right? So you would just plug back in, you would go 3 times 7 plus 1 to the 2/3 power, and you get 12. And then you would do that again, 3 times negative 9 plus 1 to the 2/3 power also equals 12. So these are both correct solutions. These are both valid solutions. Now, if I were to plug this in and I get a number other than 12, then I know it's extraneous, right? So I would it would be an extraneous solution. That's mathed up.